What if everything you thought you knew about gravity, the force that quite literally keeps us grounded, was just, well, the tip of the iceberg?
Okay.
What
Well,
if it's not what we've been told, this sort of simple, predictable pull, but something far more fundamental, maybe even, well, magical isn't quite the right word, but definitely deeper.
okay. So you're saying challenge the basics.
Exactly. Today, we're embarking on a deep dive that really challenges our most basic understanding of gravity. We often think of it as this, well understood, measurable
A
force.
cornerstone of physics, yeah.
Right. But the collection of sources we've gathered for you,
Wow.
they reveal it as one of the greatest, most profound, unsolved mysteries of our time.
It really is still a huge puzzle.
And they propose it's not just a force, but potentially the very fabric of our perceived reality. Like it's actively shaping everything we experience.
That's a big claim.
It's going to be a truly mind-expanding journey, I think.
Indeed. And our mission for you today is to entirely reframe your understanding of gravity.
Reframe it. How so?
Well, we're going to move well beyond just its measurable effects, the how it works, which, let's be honest, we've gotten incredibly good at describing.
We can predict orbits, launch probes.
Precisely. But we want to delve into its true, essential nature. Our sources explore concepts that position gravity not merely as a passive force acting on things, but as an active observer, and even a world renderer.
Observer, world renderer. Okay, that sounds wild.
It is. The goal here is to explore a new, revolutionary paradigm that tries to harmonize gravity with quantum theory.
The big unification problem.
Exactly. But maybe in a new way, offering a fresh, profound perspective on the very medium we live in. We'll be unpacking some truly groundbreaking concepts so they could fundamentally change how you perceive everything around you.
From the cosmos right down to it.
Down to your own consciousness, potentially.
Yeah, and the sources for this deep dive are they're incredible. A really rich collection of provocative insights. They demand really a fundamental rethinking of core physics principles.
It's in the boundary.
Totally. We're talking about ideas that resonate with, the kind of thinking you see from figures like Roger Penrose or Eric Weinstein, really pushing the edges of conventional science.
It takes that kind of thinking sometimes.
They challenge us to look at gravity with fresh eyes, to question these deeply ingrained assumptions we have, and just open our minds to a reality that might be far more dynamic than we've ever imagined.
It's not just tweaking the existing models.
No, this isn't about incremental adjustments. It feels like they're calling for a complete paradigm shift.
Exactly. And this deep dive, it's designed to connect these seemingly separate realms. Physics, consciousness, even the nature of experience itself.
Which usually live in different boxes.
Right. We're going to explore how these elements might be intricately linked, not just loosely associated, but maybe fundamentally unified through gravity.
Gravity as the bridge.
That's the idea. We're promising some profound aha moments, hopefully, that will leave you questioning the very underpinnings of your reality, and maybe even your place within it.
Sounds like a journey into the deep end.
It's definitely a journey into the deepest questions of existence, yeah.
Okay, let's dive in then. Let's unpack this grand enigma, starting with gravity's true nature, which our sources argue pretty profoundly is far more misunderstood than almost anything else in physics.
It's kind of amazing when you think about it.
Here's the core paradox they highlight. Science can measure and predict gravity's effects with astounding precision, right? We launch satellites, predict planetary orbits centuries ahead.
Model entire galaxies. The accuracy is phenomenal.
Phenomenal. Yet, when we ask what gravity actually is, its fundamental essence, its intrinsic identity, it remains, as our sources put it, one of the greatest unsolved mysteries of our time.
It's like we know exactly how it pushes and pulls, but not what is doing the pushing and pulling.
Yeah. It's like we've perfected the user manual without ever opening the box to see what's inside. It's bizarre.
That's a truly crucial distinction, and it's really where the reframing has to begin. We have these incredibly robust mathematical frameworks for how gravity behaves.
Newton, Einstein.
Exactly. Newton's laws nail the apple falling from the tree, everyday stuff.
Yeah.
And Einstein's general relativity beautifully explains the bending of space-time, the dynamics of the cosmos. These equations are just remarkably accurate.
They let us build bridges, design spacecraft.
Explore the universe. But the fundamental why and what behind it, its essential nature, that's still elusive. Think about other fundamental forces. Electromagnetism, for instance.
Right. Mediated by photons.
Exactly. We understand it's mediated by photons. We have a clear particle explanation, a deeper But for gravity, it's a different story. There's no universally accepted quantum description yet.
The elusive graviton? Or maybe not.
Or maybe not, as these sources suggest. This is precisely where we need to reframe our thinking. Move past just the observable effects, the measurements, and really question its intrinsic identity.
So looking at gravity not just as a force.
But maybe as a foundational aspect of reality itself.
Yeah.
Something that underpins everything, yet its true nature remains well-veiled.
And speaking of fundamental, our sources directly challenge a really common perception in physics. You hear it all the time, that gravity is inexplicably weak.
Oh, yeah, the weakest of the four forces. That's standard textbook stuff.
Right. Physicists often highlight how much weaker it is compared to, say, the electromagnetic force, especially when you look at tiny particles interacting. But our sources emphatically state gravity is the primary governing force of the universe.
Whoa. Okay, that's a bold statement.
It's not just bold, it's a direct contradiction of that widely accepted notion, and it forces us, really, to reconsider everything we thought we knew about its power.
It absolutely does.
Yeah.
And it asks us to distinguish between strength, maybe, and influence or scope at different scales. How could something perceived as weak at the atomic level?
Right, where electromagnetism dominates.
How could that same thing be so overwhelmingly powerful on a cosmic scale that, as the source says, gravity is so strong that it shapes all celestial objects?
That's the paradox.
Think about it. Every star, every planet, every galaxy, every cluster of galaxies, their very structure, their existence in the form they take, their dynamics, their evolution over billions of years.
It's all gravity.
It's all a direct, undeniable result of gravity.
Mm.
Without gravity, there are no stars, no planets, no galaxies, no us. The sheer scale of gravitational influence.
Mm-hmm.
It's staggering.
From dust clouds to superclusters.
Exactly. From the smallest cosmic dust cloud starting to clump together into a planetesimal, all the way up to the largest galactic supercluster holding trillions of stars together over cosmic history. When you consider its domain of influence, which is the entire observable universe,
Yeah.
the idea of it being weak becomes almost, well, absurd in that context. Its power isn't just in its individual tug between two small things close together, but in its cumulative, omnipresent sculpting of the entire cosmos.
Okay, so it's about scale and scope, not just particle-level interaction strength.
Precisely. And here's where it gets really interesting and provocative. Our sources push this further. They delve into this startling comparison that really brings home this re-evaluation of gravity's power.
What's the comparison?
They ask, how could the strong nuclear force holding protons and neutrons together be stronger than Big Bang black hole and planetary mechanics?
Okay, wait. The strong force is incredibly strong, right? Binds atomic nuclei.
Immensely powerful, yes. But, and this is the key, it operates at an incredibly tiny subatomic scale, literally binding the nucleus of an atom together. Its influence drops off precipitously over even minuscule distances.
Like superglue that only works up close.
Exactly like that. Gravity, on the other hand, while it might seem weaker at those tiny atomic distances, it dictates the dynamics of the entire universe. It was the driving force in the moments right after the Big Bang, shaping the universe's expansion, the formation of the first structures.
It governs black holes, stars, galaxies.
Over billions of light years. The sheer mass and energy involved in these cosmic phenomena employ a pervasive foundational power for gravity that just dwarfs the strong nuclear force in terms of its universal influence and shaping capability.
So the comparison isn't about which force wins in a tug-of-war between two protons.
No. It's about which force is the ultimate architect of the universe as we know it, and the sources emphatically point to gravity.
The profound implication, then, is that if gravity shapes everything, from the smallest asteroid to the largest supercluster of galaxies, its influence is just far more pervasive and powerful than we typically imagine.
Much more.
It's not just a force among equals, it's fundamental to every structured object in existence, like the bedrock.
The very bedrock of reality, yeah. It's not simply about making things fall down, it's about making things be in their specific organized forms. Without gravity, there's no structure, no complexity, no universe that could even foster life or consciousness. It's the ultimate organizer.
Wow, okay. And adding to this foundational role, our sources highlight another truly immense characteristic. Gravity and EM have infinite range.
That's not a small detail.
Yeah.
That's colossal. It differentiates them profoundly from forces like the strong and weak nuclear forces.
Which are very short range.
Extremely limited range,
Yeah.
yeah. Confined pretty much to the atomic nucleus.
So infinite range. What does that really mean for the universe?
It means its influence never truly ends. It extends boundlessly, never quite diminishing to zero throughout the entirety of space.
So theoretically, every particle in the universe is gravitationally pulling on every other particle, no matter how far.
That's the implication. There's no shielding from it, no true escape. It's a truly universal cosmic embrace,
Hmm,
an unbroken connection.
that's kind of mind-blowing.
And this infinite reach has profound implications. It means the gravitational field of, say, a galaxy billions of light years away is still, however, infinitesimal.
Still affecting us here.
Still affecting us here on Earth and vice versa. It creates this continuous, unbroken web of connection throughout the cosmos. It implies a deep, inherent interconnectedness of all things.
It's the ultimate network.
Exactly. This omnipresent influence is a key part of what makes gravity the primary governing force. It's not just local, it's global and universal in its reach.
You know, to bring this idea home, maybe a bit pop culture, think about Obi-Wan Kenobi in Star Wars.
Okay, the force.
Yeah, talking about the Force. An energy field that surrounds us, penetrates us, and binds the galaxy together. Our sources almost give gravity a similar, maybe not mystical, but certainly pervasive quality. Its range extends infinitely.
It's a useful analogy, actually.
It feels like it's not just a theoretical concept, but this ever-present, all-encompassing field that is the fundamental medium we exist within, like the actual stuff of reality.
And to ground that back in the physical implications, this infinite range explains why the largest body of mass in any given location will gravitationally swirl smaller bodies of mass.
We see that everywhere.
Everywhere. Galaxies spiraling around supermassive black holes, solar systems with planets orbiting a star, moons orbiting planets. It's the observable, geometric dance of the cosmos.
But the sources hint at something deeper.
Yes, they hint at an even deeper implication, suggesting this swirling and shaping isn't just for celestial bodies, but potentially extends to the formation of conscious observers themselves.
Wait, gravity forming conscious observers? How?
Well, it implies a kind of gravitational blueprint for the emergence of organized complexity, up to and including consciousness. This constant gravitational interaction is fundamental to how structures, including those that might give rise to conscious perception and interaction, can even begin to form and entangle.
So the universe literally shaping itself into observers through gravity.
That seems to be the implication, yeah. It's the ultimate self-organizing principle.
Okay, that's where we start to really shift perspective then. Seeing gravity not just as a force, but as this active participant in the very construction of reality.
Exactly.
And our sources introduce a truly mind-bending concept here, that gravity actively engineers and measures quantum information.
Engineers and measures.
Yeah, not just a passive puller. It's intimately involved in the universe's fundamental information processing, like a cosmic architect and accountant, maybe, constantly designing and taking stock.
That's a radical idea. Gravity as an information processor.
And here's where it gets really interesting for you, the listener, and for our understanding of reality. Our sources assert that gravity is also responsible for your perception of time.
Okay, not just time dilation near black holes.
No, not just about how clocks tick differently in strong gravitational fields, which we know happens. It's a measurable effect. This goes far deeper.
How deep?
It's about your fundamental lived experience of reality, the very flow of moments that define your consciousness, your sense of before and after, your personal narrative.
My subjective experience of time passing.
Exactly. Gravity isn't just bending space, it's shaping your internal clock, your subjective sense of duration, the very structure of your experienced reality.
Wow, okay. That's profound.
This leads directly into the central, really revolutionary thesis from our sources, a complete flip of the traditional view. Gravity is the observer, the world renderer, the space-time projection.
Observer, world renderer, space-time projection, all gravity.
That's what they propose. It completely reframes gravity, making it an active, almost conscious-like agent in the universe, rather than just a passive force.
So it's not simply in reality.
It is the one making reality real for us, or at least mediating its appearance. But what exactly do they mean by observer and renderer? Is it like a cosmic consciousness?
Yeah.
Or something more mechanistic?
That's the crucial question, isn't it? When the sources refer to gravity as the world renderer, it suggests that the reality we perceive isn't just out there, objectively, fully formed, just waiting for us to stumble upon it.
Okay.
Instead, it suggests reality is actively constructed, displayed, brought into being by gravity itself.
Like gravity as a cosmic projector.
That's a good analogy. Constantly rendering the universe onto the screen of our perception. It's a profound shift from thinking about a static external reality to one that is dynamically generated, an ongoing process.
Is it implying consciousness in gravity itself?
Not necessarily consciousness in the human sense, I don't think, but rather a fundamental active role in the manifestation of what we call reality. Gravity provides the very framework and mechanism for reality to appear in a specific, coherent way. It sets the rules of the game.
And a crucial link in this rendering process, our sources tell us, is this intricate relationship between light and electricity.
Light and electricity, fundamental.
They state, all electrons are mediated by photons, therefore all electricity is mediated by light, which basically establishes light photons as the fundamental carrier of electrical information.
Which is central to our sensory experience, our brain activity.
Exactly. It's like the universe's internal communication system.
Okay, so building on this, if gravity is the observer mediating light.
Like near a black hole where light gets totally warped.
Exactly like that, where gravity's influence is extreme, literally bending light around itself. If gravity's doing that everywhere, maybe more subtly, then our perceived reality becomes something quite extraordinary.
How so?
It becomes, as the sources put it, a gravitational observer using light to mediate electrical sensorial experience.
Okay, break that down. Gravitational observer using light to mediate electrical experience.
It means that our senses, our entire electrical brain activity, the very act of seeing, hearing, tasting, feeling the world, might be fundamentally tied to gravity's observational and rendering role.
So gravity sets the stage.
Gravity sets the geometric stage, the curvature of space-time. Light carries the raw informational data, the photons bouncing off things. And electricity, the electrical impulses in our neurons, processes it into what we call experience.
Wow. So it's this deep intertwined dance between gravity, light, and electricity, orchestrated by gravity.
That's the picture they paint, a fundamental orchestration.
So what does this all mean for you, the listener? What's the takeaway? It means experience is light filtered by geometry and rendered by electricity.
That's a concise way to put it.
Gravity provides the geometry, the curved space-time itself, acting like a lens or a filter. Light provides the information, carrying the raw data. And electricity, specifically in our brains and nervous systems, makes it palpable. Turns that filtered, geometrically shaped information into your conscious, subjective experience.
It's a stunning realization, isn't it? Your subjective reality is, in a very real sense, essentially a gravitational construct, a personal rendering of the universe mediated by light and electricity.
It really emphasizes this profound shift in perspective you mentioned earlier.
Definitely. We're moving from this view of an external, purely objective reality that we just passively observe.
Like watching a movie.
Right? To an actively constructed one where gravity plays this pivotal dynamic role in creating the framework, the canvas, if you will, upon which our experiences are continuously painted.
Implying this intimate, dynamic, inseparable relationship between gravity, light, electricity, and our very consciousness.
It's not just about how the universe works out there. It's about how you perceive and interact with it fundamentally.
Okay. Circling back to a foundational idea from our sources, they reiterate that gravity is what gives everything structure and usefulness.
Structure and usefulness.
It's not just about enabling existence. It's about organization, coherence, purpose. It's the sculptor's hand, maybe.
Exactly. And this fits perfectly with the renderer concept we were just discussing.
Yeah.
Without gravity, the universe would essentially be, as the source puts it, a featureless void.
Just chaos.
A chaotic soup of particles and energy,
Yeah.
Devoid of any discernible organization or form. It is gravity that creates the order, the shapes, the specific configurations that allow for complex structures to emerge.
From galaxies down to
the elegant spiral of a galaxy, the intricate design of a molecule, the delicate balance of an ecosystem, and ultimately the very possibility of life and consciousness. Gravity doesn't just collect things, it organizes them.
into stable, functional, interacting systems.
Precisely. It's the force that allows for complexity, for usefulness, for the very idea of a thing being distinct from its surroundings. It makes interaction possible.
Now, if gravity plays such a profound role in shaping our perceived reality, it must fundamentally alter our relationship with time itself, right?
Absolutely.
Our sources make a truly bold claim here, one that really makes you stop and think. Investigating gravity makes you throw away your clock.
Throw away your clock. That's quite a statement.
It's not just a metaphor for relativity, is it? It seems to hint at the non-absolute, malleable, perhaps even illusory nature of time, profoundly influenced, maybe even generated, by gravity.
It absolutely does. That statement challenges our deeply ingrained, intuitive understanding of time as this universal, unchanging constant, a river flowing at the same speed for everyone.
But it's not like that.
It appears to be real and passes at a consistent rate for us, here, now. But this is a specific experience tied to our local gravitational context, here on Earth. The sources emphasize that each observer experiences time differently.
My clock isn't your clock, essentially.
On a fundamental level, relative to gravity, yes. Your clock, your perception of time, your personal history, they're all relative to your position within the universe's gravitational landscape. It's not a universal constant. It's a personal, gravitationally tuned experience, a local construct.
And we know this on a cosmic scale, right? Time dilation isn't just theoretical.
Not at all. It's a well-established phenomenon. Our sources discuss how time moves slower and becomes more infinite the closer you get to a larger gravitational mass.
Like near a black hole, time almost grinds to a halt for someone watching from afar.
Exactly. Or even much more subtly, astronauts on the International Space Station experience time fractionally faster than we do down here on Earth.
Because gravity is weaker up there.
Precisely. This isn't science fiction. It's measured reality. Clocks literally tick at different rates depending on the local gravity.
And conversely, as the sources say, gravity weakens with increased distance from the central mass.
And in these regions, time appears to be real and passes more quickly. It demonstrates this direct, inverse relationship between gravitational strength and the felt or measured pace of time.
Further away from the mass, faster time flows, relatively speaking.
Correct. And this isn't just an abstract concept. It has very practical applications. Think about GPS satellites.
Right, they need super precise timing.
Extremely precise. Their atomic clocks, critical for pinpointing your location, must be constantly adjusted to account for both their speed and their higher altitude where there's weaker gravitational pull. If they didn't make those relativistic corrections,
GPS wouldn't work.
it would become inaccurate by several miles within a single day,
Right.
rendered completely useless. So this everyday technology we rely on serves as a constant, tangible reminder of gravity's subtle but real mastery over time.
Okay, that's fascinating. But our sources take this concept of diverse experiences and apply it to conscious observers in a really interesting, almost philosophical way.
Oh, so?
They offer these vivid examples that suggest gravity profoundly shapes our very worldview, how we perceive reality itself, they say. When you talk to someone with a little gravitational mass, they are always talking from separation, time, and their stories being real, local realism, or materiality being true.
Okay, little gravitational mass. Talking from separation, time is real.
Yeah.
Like a standard materialist view.
Kind of sounds like it. And then, contrasting this, they say, when you talk to someone with an infinite gravitational mass, they are always talking from non-separation, time, and their stories are unreal, non-local realism or projection is true.
Infinite gravitational mass. Non-separation, time is unreal. Non-local realism. Wow. Can you unpack those? What does it truly mean to have little versus infinite gravitational mass in terms of perception? Is this metaphorical?
It seems metaphorical, but with deep physical underpinnings based on their model.
Okay, let's try to unpack it. These aren't just abstract physics ideas, then. They seem to offer this profound lens for understanding different perspectives on reality itself, extending maybe into psychology, philosophy.
Right.
So, someone described as operating from a little gravitational mass. Metaphorically, they might perceive a fixed material world. Objects are distinct, separate. Time flows linearly, absolutely.
My story is my story, your story is yours.
Exactly. This aligns pretty well with what physicists and philosophers call local realism, the idea that objects have definite properties whether you look or not, and influences only travel locally, not instantaneously across distance. For such an observer, their stories, their experiences are concrete, ordered, distinct. Reality feels solid, tangible, material.
Okay, that makes sense as a common viewpoint. Now, the infinite gravitational mass perspective.
Conversely, someone operating from metaphorically an infinite gravitational mass would perceive things very differently. A more fluid, maybe projected reality where distinctions blur, where non-local connections, think quantum entanglement, are paramount.
So separation is less real.
Less fundamental, yes. Time and individual stories might be seen as unreal, or perhaps as mere projections onto a deeper unified background. This points towards non-local realism, a view often associated with quantum mechanics, where particles can be instantly connected regardless of distance, and reality might be more about potential and interconnectedness than fixed states.
Like seeing the whole web, not just the individual threads.
Exactly. For these observers, there's a sense of non-separation, of interconnectedness. The individual narrative becomes less significant than the universal flow or the underlying unity. It suggests that gravity, or maybe our relationship to gravity in this metaphorical sense, fundamentally shapes our worldview, our philosophical stance on reality itself.
So whether you perceive a fixed material world or a fluid projected reality might be linked to your gravitational state.
That's the implication. It's a deep idea suggesting our subjective experience, our sense of self, our connection to others, is somehow profoundly modulated by this underlying gravitational reality.
Yeah.
Your gravitational footprint isn't just about physical mass, maybe, but about how you perceive and construct your reality.
That's a lot to chew on. And it brings us to another incredible assertion from the sources.
Which is?
They imply gravity plays a fundamental role in how conscious observers entangle and take shape.
Gravity involved in conscious observers taking shape and entangling.
Yeah. This is a huge leap, right? Connecting gravity not just to physical structures like stars and planets, but to the very formation and intricate interconnectedness of consciousness itself.
It sounds like gravity isn't just the stage anymore.
But maybe part of the cast? Especially the audience, if it's the observer.
That's precisely the implication.
Yeah.
If gravity is the observer and the renderer of reality, as these sources propose,
Yeah.
and if it orchestrates the very geometry and flow of information, then it's not such a huge stretch, conceptually, to think it's deeply involved in the very conditions that allow for conscious observation to emerge in the first place.
So it dictates how mass congregates, how energy flows.
How information gets processed into geometry and light, then the intricate connections, the entanglement between conscious entities could also be seen as an extension of this gravitational shaping and interaction.
Gravity co-creating consciousness.
It suggests that our consciousness isn't just happening in a gravitational field, but that gravity might be actively co-creating the conditions for consciousness to be. And for different consciousnesses to connect, to entangle, it literally shapes the possibility space for awareness to coalesce and interact within the universe.
Mind blown. Okay. Let's talk about perhaps the biggest, most persistent challenge in modern physics, unification.
Ah, yes, the Holy Grail, unifying general relativity and quantum mechanics.
Exactly. General relativity elegantly describes gravity on the grand scales, cosmos, galaxies. Quantum mechanics brilliantly describes the incredibly small, the subatomic world. They both work perfectly in their own domains.
But they clash dramatically when you try to bring them together. Their fundamental descriptions of reality seem incompatible.
Right, and our sources offer this powerful yet kind of simple metaphor for why this unification has been so difficult, they say. Trying to quantize gravity is like trying to have the canvas in the same category as the paint.
Ooh, I like that. Canvas and paint.
What does that analogy really tell us?
I think it clarifies the core problem beautifully and highlights the radical shift in thinking that might be required. Historically, physicists trying to unify forces look for a quantum particle, a graviton, to mediate gravity.
Like photons mediate electromagnetism, find the gravity particle.
Right, but this analogy implies you don't quantize the canvas itself, the fundamental medium, the space-time that gravity seems to represent. Instead, you put quantum paint, the particles, the fields, the discrete packets of energy, the quantum fluctuations on the canvas.
So gravity isn't a force within space-time that you can break into bits.
Exactly. This suggests gravity is space-time, or the medium itself. The underlying, perhaps continuous framework upon which all the quantum phenomena unfold. It fundamentally redefines gravity's role, from just another force to the very stage of existence. You don't quantize the stage, you put the quantum actors on the stage.
And the sources are pretty direct about what this means for those traditional approaches, the ones that have dominated theoretical physics for decades.
They don't hold back.
No. They explicitly state there is no graviton particle, dead end.
Wow, just dead end.
And then maybe even more provocatively, strings are part real, part fake.
Okay, taking aim at string theory too.
These are incredibly strong, almost dismissive statements. They signal a need to perhaps abandon certain traditional avenues of research that have consumed generations of brilliant minds. What makes these claims so profound, so challenging to the scientific establishment?
Well, they're radical departures. That's why they're provocative. The graviton, this hypothetical elementary particle, has been the main target, the Holy Grail, for many physicists working on quantum gravity for decades. Decades of searching, theorizing.
Billions of dollars in research.
Right, so if there's no graviton particle, flat out, It means that the entire premise of quantizing gravity into a particle like we successfully did for photons with electromagnetism or gluons with a strong force is potentially fundamentally misguided.
We've been looking for gravity in the wrong way, trying to fit a square peg into a round hole.
That's what it suggests. And as for strings are part real, part fake, that directly addresses string theory.
Which is probably the most famous attempt at a theory of everything.
Yeah. Exactly. It proposes that fundamental particles aren't points, but tiny, vibrating strings. And it's offered this very promising, mathematically elegant, although incredibly complex, framework for unifying all fundamental forces, including gravity, because gravitons naturally emerge within its structure.
But it hasn't been experimentally verified.
That's the major sticking point. While it's mathematically beautiful and solves some theoretical problems in quantum gravity, there's no experimental proof yet. So by calling it part real, part fake, the sources seem to imply that while some of its mathematical structures or insights might hold value, its core premise of describing gravity through discrete strings, and therefore implicitly through gravitons, might be fundamentally flawed in how it conceives of gravity's true nature. It's a call to rethink the very foundational assumptions of these huge research programs.
So if quantizing gravity is deemed a dead end, and established theories like string theory are being questioned in their core approach to gravity, what's the path forward according to these sources?
They propose a truly revolutionary idea.
Yes.
Instead of trying to quantize gravity. Yeah.
We should gravitize quantum theory.
Gravitize quantum theory. That sounds like a complete inversion of the problem.
It is. And it's really the core of the new physics being proposed in these materials. It's a monumental conceptual shift.
So explain that. What does gravitizing quantum theory actually mean?
It means it's not about forcing gravity to fit into the existing quantum mechanical framework by breaking it into particles. It's about integrating quantum phenomena into a fundamentally gravitational understanding of reality.
Seeing quantum mechanics through the lens of gravity?
Precisely. Recognizing that gravity isn't just another force to be quantized, but the pervasive medium, the canvas itself. So instead of trying to find quantum aspects within gravity, we should understand how quantum phenomena arise from or are governed by this underlying gravitational reality.
And this isn't just some completely out there idea. Well, it's definitely unconventional, but it's not without serious proponents. Our sources credit Penrose, Weinstein, Atlas, others. These are major figures. It gives it significant intellectual weight and suggests maybe there's a growing consensus among some leading thinkers that a completely new path is necessary.
Right. And to elaborate on that, gravitizing quantum theory means recognizing, as the sources say, that both have aspects of the other in them.
A symbiotic relationship.
Yeah. It's about finding the inherent gravitational nature within quantum mechanics, rather than trying to impose quantum discreteness onto the smooth fabric of gravity described by Einstein. It feels more organic, maybe. An integrated approach suggesting a deeper relationship than we previously assumed.
Exactly. And this leads to a potentially elegant and profound understanding of how quantum potential actually becomes reality, how the weirdness of quantum mechanics resolves into the classical world we experience.
How does that work in this model?
Our sources state that quantum superposition, entanglement, potential, probability belong to singularity.
Okay. Singularity again. Usually we think of the center of a black hole.
Right, the point of infinite density.
Yeah.
But here, the singularity seems to be presented more broadly, not just as a cosmic extreme, but as the fundamental realm where all quantum possibilities exist in their raw, unmanifested, probabilistic state.
Like the source code, the realm of pure potential.
That's a great way to put it. The ultimate realm of pure potential, where everything is possible simultaneously, but nothing is yet actual. The superposition of all states.
Okay, so you have the singularity holding all quantum possibilities. Then what?
Then, the singularity, which holds all these possibilities, contracts it down to a single outcome.
Collapses the possibilities.
Exactly. It collapses them down to one specific actuality, which then appears geometric and rendered as light and information or quantum fields.
That sounds very much like the collapse of the wave function in standard quantum mechanics, where measurement forces a choice. But here, gravity or the singularity is doing the collapsing.
That seems to be the idea. Synthesizing this, it suggests that gravity, through this concept of the singularity, acts as the ultimate bridge. It takes the myriad quantum potentials, the superposition, the entanglement, all that probabilistic weirdness, and collapses them, contracts them into the deterministic geometric reality we perceive.
The classical world emerges from the quantum foam mediated by gravity.
Right, and this emergent reality is then rendered and conveyed by light and information, which we describe using the language of quantum fields. This is the very mechanism by which the observer, which our sources identify fundamentally as gravity itself, actualizes our world, brings form out of formlessness.
It's how the universe goes from being this wave of probabilities to a concrete, observable, geometric experience.
Which is then mediated and filtered through light and electricity to our consciousness. This really feels like the heart of building that new physics. Gravity as the observer, harmonized with quantum theory as its appearance, its manifestation.
The magnitude of this shift is just immense. Our sources conclude that what's really needed is a new physics that brings together gravity with quantum in a whole new paradigm.
A whole new way of thinking.
And, quoting again, an entirely new model of the medium we live in is the answer. This isn't just about tweaking existing theories or adding a new particle. It's a fundamental reimagining of existence.
Like tearing up the old map of the universe and drawing a completely new one.
Exactly. And that's the profound implication for you, the listener. This isn't just incremental science happening in labs. It's a call for a fundamental reimagining of existence itself.
How you fit into it all.
Right. It means the very space we inhabit, the very fabric of reality, needs to be defined and experienced through an entirely new lens of gravitational and quantum harmony. It challenges us to build from the ground up, rethink every assumption about the universe.
And ultimately about our own place within this gravitationally rendered reality. It's about shifting from thinking about gravity as just a force to maybe thinking through gravity as the foundational layer of everything we experience.
Okay, let's try to bring this all back to something visual, something we can actually observe. Gravitational lensing.
Ah, yes. Einstein rings and arcs. Beautiful cosmic phenomena.
Exactly. This is where light from distant objects, like galaxies, bends and warps as it passes massive objects closer to us, often into an arc or even a complete ring shape. Astronomers observe this regularly.
It's direct, undeniable proof that gravity bends light, warps space-time, just as Einstein predicted.
But it's not just an astronomical curiosity, according to these sources.
No. They connect this visual directly to the core concept we've been discussing, stating it goes from a ring into microconstructionism.
From the cosmic ring down to the micro level.
Exactly. This bending and warping of light by gravity isn't just happening on galactic scales billions of light years away. It's presented as a physical manifestation of how gravity, acting as the observer and renderer, manipulates light to construct our reality, even on a micro level. Moment by moment, right here, right now.
Wow. And the sources describe this with an incredibly vivid, almost poetic phrase. What was it?
An inescapable well of curved space-time, light, electric senate lucid dreamed experience.
Okay, let's unpick that. Inescapable well of curved space-time.
That sounds like our existence within gravity's influence, within the geometry it creates.
Yeah.
We're in the well.
Light electric senate.
That seems to refer back to how light carries the information, which is then processed by our electrical nervous systems, our senate, forming our conscious awareness. It's like this collaboration between light and electricity to create perception within the gravitational framework.
Lucid dreamed experience.
Suggesting our perceived reality, while coherent and seemingly solid, might have qualities of a dream, actively constructed and perhaps malleable, mediated by gravity.
So this isn't just a metaphor. It's suggesting the very process of reality appearing to us, down to the smallest detail, is a direct result of gravity constantly constructing our light electric experience within this curved space-time.
A continuous active rendering, that's the implication. It's reality as an ongoing gravitational performance.
And this leads us right to the ultimate challenge, doesn't it? The boundary where physics, as we currently understand it, seems to meet something else entirely.
The edge cases, the extremes.
Right. Our sources state, the reason why no cosmologist or physicist can tell you what happens when gravity becomes infinite and creates a hole in space-time,
Like inside a black hole, singularity.
is because that's where mysticism and consciousness takes over.
Mysticism, consciousness taking over from physics.
That's what it says. Is this just a poetic statement, or does it imply a genuine limit to our current scientific paradigm? Why does physics seem to stop here?
I think this is incredibly significant. And is not necessarily presented as a failure of science, but maybe as a profound pointer. A signpost to a realm beyond our current purely physical models.
So when gravity reaches its absolute extreme, becomes infinite, like in a singularity, it just transcends our current math and concepts.
It seems so. At that point, the very fabric of space-time, light, information, causality, it all breaks down in ways that our current equations and theories simply cannot describe. They yield infinities, which usually means the theory is incomplete.
The physics breaks.
Right. It suggests that at this boundary, the conventional tools of physics become insufficient.
Yeah.
And we might enter a domain where the role of consciousness itself, or what we might perhaps call mysticism or subjective experience, becomes paramount in defining what reality even is at that point.
So it's where the physics of the observer gravity becomes indistinguishable from the observed, from consciousness itself.
That seems to be the profound suggestion, where the deepest mysteries of the universe and consciousness converge. It implies that at the very edge of gravitational understanding lies potentially the key to the fundamental nature of experience and existence itself. Maybe the ultimate truth of reality isn't just equations, but something involving consciousness woven into the fabric.
Wow. Okay. So let's try to recap what we've unpacked today. It's been quite a journey.
It certainly has.
We've dared to rethink gravity, not just as this simple, predictable force.
Pulling apples off trees.
Right, but as the fundamental observer and the active renderer of your reality, the architect of your perception of time, and the very medium that potentially harmonizes the weird quantum world into the coherent, geometric reality you experience every single moment.
We've seen how it structures everything, from the vast expanse of galaxies right down to, potentially, the intricate workings of our own consciousness.
We've definitely moved beyond that traditional view of gravity as just a weak, simple force.
Absolutely. Replacing it with this dynamic, potentially conscious-shaping, reality-rendering entity outlined in our sources, it's a complete reimagining of its power, its pervasive influence on all existence, and its role as the fundamental canvas upon which all other phenomena unfold.
And this deep dive suggests that by gravitizing quantum theory, as the sources put it, by embracing an entirely new model of reality where gravity is the primary observer and quantum phenomena are its appearance.
We might finally bridge that seemingly intractable gap.
Between the grand scales of the universe governed by gravity and the microscopic world of quantum mechanics, and maybe even connect it all back to our own consciousness.
It's a profound call to look at the universe through a completely new lens, one that puts gravity right at the very heart of existence and experience.
Okay, as we close, here's a final provocative thought for you, the listener, to mull over based on everything we've discussed.
All right, leave them with something to think about.
If gravity is truly the world renderer, using light and electricity to construct your experience of reality, what does that mean for the nature of your own free will?
Free will in a rendered reality.
Yeah. If your reality is actively rendered, how much of that rendering are you, as a conscious observer within that system, actively, perhaps gravitationally, observing into existence through your own perception, your focus, your interaction?
How much influence do we have on the rendering process itself?
Exactly. How much of your reality are you actively observing into being? Something to think about in your daily life.